A Harvard astrophysicist has just released his 15th anomaly report on a single object. 15 individual behaviors, each one on its own, demanding an explanation science doesn't currently have. And the one drawing the most attention right now is this. 3IATLAS fired a tightly focused beam of light directly at the sun, not away from it, toward it, with an opening angle of only 6 to 8 degrees. And it held that precise geometry for months, across tens of millions of kilometers, both before and after perihelion. Avi Loeb, who holds the longest continuously held chair in Harvard's Astronomy department, wrote publicly that this is a non-trivial anomaly for a natural comet, that a jet this tightly focused, this persistently stable, and this geometrically precise isn't explained by conventional sublimation physics. He's calling it anomaly number 15, and he's not finished counting. This is the full story of everything strange that 3IATLAS has done since it showed up in our sky. What it fired, what changed color, what accelerated when it shouldn't have, what Loeb actually said in peer-reviewed papers versus what the internet turned that into, and what it all means for a civilization that just watched something from another star system pass through our neighborhood, fire a beam of light at the sun, and leave without ever slowing down. July 1st, 2025. An automated telescope in Chile named ATLAS picks up a faint moving object. The orbit gets calculated, then recalculated, then a third time. The eccentricity comes back at 6.14. Anything above an eccentricity of 1 means an object isn't gravitationally bound to our sun. An eccentricity of 6.14 means this object isn't even close to bound. It's the most extreme trajectory ever recorded for anything observed in our solar system. Nothing we've ever tracked comes near this number. The object is immediately flagged as the third confirmed interstellar visitor, following Oumuamua in 2017 and Borisov in 2019. It's named 3IATLAS, the third interstellar object discovered by the ATLAS survey. And from day one, nothing about it has behaved the way it was supposed to. Within hours of confirmation, the early imaging already showed something odd. The comet had a coma, a cloud of gas and dust around the nucleus, expected. But the shape of that coma wasn't. The first Hubble image came on July 21st, 2025, and what it showed stopped the analysis team cold. On one side of the nucleus, a normal coma extended away from the sun, as expected. On the other side, a jet of material extended toward the sun, and not a faint smear either. The projected elongation in the Hubble image came out to roughly 2 to 1, which, once corrected for viewing angle, translated to a three-dimensional structure about 10 times longer in the sunward direction than in any other direction. Loeb and his colleague Eric Quito measured it, modeled it, and published the initial finding. They called it a sunward anti-tail, a feature pointing toward the sun instead of away from it. Solar system comets occasionally show something that looks like an anti-tail, but it's always a perspective trick, a geometric illusion that happens when Earth crosses the plane of a comet's orbit and briefly sees a dust sheet edge on. Those are temporary. They vanish once the viewing angle shifts. They aren't real physical structures pushing back against solar radiation. What 3IATLAS showed was different. It wasn't a perspective effect. It persisted for months. It was there in July before perihelion. It was still there in August, as the comet also developed a normal outward tail. It dropped from view in October when the comet passed behind the sun. And when 3IATLAS reappeared in November 2025, after rounding the sun at closest approach on October 29th, the anti-tail was back, still pointing sunward, still tightly focused, still geometrically strange. By December 14th, 2025, with 3IATLAS 270 million kilometers from Earth, amateur astronomers in Thailand and Germany, using modest gear, were still clearly capturing the sunward feature in their processed images. Rotation gradient brightness maps confirmed it plainly, a prominent extension pointing straight at the sun, which directly defies the basic expectation of what solar radiation pressure does to comet material. Loeb kept publishing on it, paper after paper, post after post, each one adding another layer to the anomaly list. He pointed out that the jet's opening angle sat between 6 and 8 degrees, which is extraordinarily narrow for any natural cometary emission. Typical comet outgassing is diffuse and roughly hemispheric, spreading across a full 180 degrees. Even the tightest jets seen on solar system comets are far broader than this. A 6-degree opening angle implies some kind of focusing geometry that ordinary sublimation off a porous, icy surface doesn't usually produce. He flagged something else, too. In July and August 2020, the rotation axis of 3IATLAS lined up within 8 degrees of the sunward direction, meaning the jet was firing essentially along the object's spin axis, pointed straight at the sun, active whenever the sunward pole faced the sun. But to produce the observed geometry, both before and after perihelion, the active region near The sunward pole before perihelion would need to be on the night side afterward, and somehow still produce a sunward pointing jet. Loeb labeled this anomaly number 15, noting that for a natural comet, it would require the emitting region to be well insulated on the night side, while still generating a tightly focused output. He described it as non-trivial for any natural explanation to account for. Now, it's worth being precise about what Loeb actually claimed versus what he didn't. His published paper, co-authored with Adam Hibberd and Adam Kroll from the Initiative for Interstellar Studies in London, was explicit. It was framed as a pedagogical exercise testing a hypothesis, not a confident claim that 3IATLAS is an alien spacecraft. The abstract states outright that the authors don't necessarily endorse the hypothesis, but consider it worth analyzing. Loeb is well known in the astronomy community for raising uncomfortable questions in public. He did the same thing with Oumuamua back in 2018. The consensus among scientists on 3IATLAS is that it's a comet of extraordinary natural origin. But Loeb's systematic cataloging of anomalies has pushed the field to engage rigorously with the data in a way that's actually been productive. So what natural explanations exist for the anti-tail? Loeb and Quito's first paper proposed that the sunward jet seen in July and August was dominated by sunlight scattering off water ice fragments ejected from the nucleus as CO₂ sublimated. CO₂ is far more volatile than water. It sublimates at much greater distances from the sun, which explains why 3IATLAS was already active and already showing a coma when first detected 4.5 astronomical units out, beyond the asteroid belt. CO₂, sublimating off the nucleus, could launch chunks of water ice large and durable enough to resist being immediately swept away by solar radiation pressure. These chunks would travel roughly sunward given the ejection geometry, reflecting sunlight and producing exactly the kind of forward-pointing glow Hubble captured. Loeb's later paper, from December 2025, proposed a swarm model instead. If roughly 1 trillion small fragments separated from the main nucleus, each carrying only a tiny sliver of the total mass, their combined surface area could be enormous, potentially 100 times larger than the nucleus itself. That swarm would then generate nearly all of the visible light, making 3IATLAS appear dominated by the swarm's glow rather than the bare nucleus. If the swarm weren't subject to the same non-gravitational acceleration affecting the main body, it would naturally drift slightly sunward relative to 3IATLAS as the two move together, producing a persistent anti-tail geometry. That fits the observations. It fits the timing. It fits the teardrop-shaped coma seen in post-perihelion images throughout November 2025. Which brings us to the non-gravitational acceleration. JPL Horizons tracking recorded a persistent non-gravitational acceleration on 3IATLAS through November 2025, a force acting on the comet that isn't gravity. The magnitude was tiny, roughly 0.02 of the sun's gravitational pull, but it was real and measurable. Non-gravitational accelerations are a known phenomenon in comets, produced by outgassing acting like a rocket thruster, pushing the nucleus opposite to the net direction of gas release. The fact that 3I seen Atlas showed a detectable non-gravitational acceleration. During the same period, it had both a sunward jet and an outward tail fits with the comet actively outgassing in an asymmetric pattern. A roughly sunward-firing jet would push the nucleus anti-sunward, which is exactly what JPL's tracking picked up. A February 2026 preprint analyzing the kinematic and thermodynamic constraints on that acceleration added another wrinkle. The measured temperature of the jet material came out to roughly 140 Kelvin, while the equilibrium temperature expected at that solar distance was around 180 Kelvin. The jet material was colder than a simple sublimating surface should produce. The researchers noted this deficit is consistent with rapid adiabatic expansion through a constricted geometry. In other words, if gas and material are being forced through a narrow channel rather than diffusing freely off a broad porous surface, it would cool faster during expansion, landing below what standard equilibrium models predict. That's not proof of artificial construction, but it is a detail natural sublimation models now have to explicitly account for. Now, about the colors. Some viral videos claimed 3IATLAS dramatically shifted from red to green. The real science is more restrained than that. Early prediscovery data from NEOWISE showed certain color characteristics at very large distances. After discovery, multiple observatories measured its spectral slope, how much redder or bluer it appears across wavelengths, landing on values between 20 and 29% per thousand angstroms across July through September 2025, numbers that hold up consistently under the best calibration. What some teams initially reported as dramatic color shifts turned out to be either genuine but more subtle changes as cometary activity, altered the coma's dust composition, or artifacts from different instruments using different filters without full cross-calibration. The honest summary: 3I Atlas's color behavior was unusual next to solar system comets, but nowhere near as dramatic as some reporting suggested. Real changes were observed, but nothing was confirmed as permanent, and interpretation is still debated. The brightness behavior was more clearly anomalous. 3IATLAS brightened steeply as it neared the Sun with a heliocentric brightening index around 3.8, meaning it brightened far faster than a simple reflective object would as solar radiation increased. For comparison, 2I Borisov's brightening index was around 2, roughly what you'd expect from an inert reflector. The steep brightening in 3IATLAS points to a rapid rise in outgassing activity, consistent with the unusually volatile-rich composition the spectroscopy revealed. A few individual brightness measurements appeared to show sudden short-term jumps, but careful review by teams at the Southern Astrophysical Research Telescope found several of those apparent outbursts were actually artifacts. Poor seeing conditions and contamination from nearby background stars as the comet moved rapidly across the sky. Not every claimed brightness anomaly survived rigorous quality checks. What did survive, cleanly and without controversy, was the composition. A CO₂ to water ratio of 7.6, more than 60 times the median for solar system comets. A CO to water ratio of 1.65, over 50 times typical values. A deuterium to hydrogen ratio 30 times higher than any solar system comet. Carbon isotope ratios unlike anything seen in any nearby stellar environment. A kinematic age putting formation somewhere between 3 and 11 billion years ago, with the latest isotopic work pushing that toward 10 to 12 billion years. An origin in the early Milky Way, under conditions of extreme cold and a chemical environment that no longer exists anywhere nearby in the galaxy. All of that is solid, replicated, published in Nature, and confirmed independently by multiple observatories using multiple instruments. Then there was the Mars flyby on October 3rd, 2025. 3IATLAS passed within 0.194 astronomical units of Mars. 2 European spacecraft in Mars orbit, ESA's ExoMars. Trace gas orbiter among them, turned their instruments toward it, capturing the first images ever taken of a confirmed interstellar object from another planet's vantage point. Those images revealed extended dust filaments and a complex outflow structure in the inner coma. NASA's Mars Reconnaissance Orbiter, with its high-rise camera capable of roughly 30 km per pixel resolution at 3IATLAS's distance, also gathered data on October 2nd. Loeb publicly pressed NASA to release those images, arguing in November 2025 that data withholding tied to the federal government shutdown was holding up the science. When the images eventually came out, they confirmed the object remained a single body. It hadn't, broken apart, and the anti-tail structure was visible from the Martian vantage point as well. The fact that 3IATLAS survived perihelion intact is itself notable. A nucleus with this extreme a volatile composition, heavily loaded with CO₂, CO, and deuterium-rich water ice, approaching the Sun to within roughly 203 million kilometers at perihelion, was, under some models, expected to show significant fragmentation or even fall apart entirely. Loeb had written explicitly before perihelion that if the object broke into multiple fragments, that would fit a natural weakly bound icy body, while unusual structural resilience would be harder to explain. When 3IATLAS emerged from behind the Sun in November, still as a single body, still showing the sunward anti-tail, still intact after peak solar heating that was itself a data point, the object holding together more coherently than many volatile-rich natural comets would be expected to under those conditions. So what does all of this add up to? Not proof of artificial technology. The scientific consensus is clear on that. 3IATLAS is a comet, an ancient interstellar comet of extraordinary composition formed in the early Milky Way under extreme cold and primordial chemistry we can't directly observe anymore. Its odd behaviors, the anti-tail, the tightly focused jet, the non-gravitational acceleration, the unusual volatiles, the steep brightening, all have natural candidate explanations that researchers are actively refining. None of them individually requires artificial construction, but Loeb's contribution, however controversial his public persona might be, has been forcing the scientific community to address each anomaly individually and rigorously, rather than slapping on the label comet and moving on. There's a version of this story where all 15 anomalies resolve naturally once you account for an extremely old, extraordinarily volatile-rich, chemically exotic object from the early galaxy, behaving in ways we've simply never observed before, because we've never encountered anything quite like it. That version is probably right. 3IATLAS is probably exactly what most planetary scientists say it is. The strangest natural comet ever observed, formed under conditions that no longer exist anywhere nearby, carrying chemistry from the primordial galaxy flung into interstellar space billions of years ago, briefly warming itself near our sun before vanishing back into the dark between stars. All of its strangeness is the strangeness of extreme nature, not of anything manufactured. But the reason this object matters, beyond the extraordinary isotope ratios and ancient origin, is what it revealed about how science actually operates. When something genuinely unprecedented enters your field of view, the instinct is to reach for the nearest familiar label, comet, asteroid, and that label can close off the question before it's been fully asked. Loeb's methodical approach to cataloging anomalies, whatever you make of his, willingness to speculate publicly about artificial origins, forced a discipline of enumeration. Here's what we expected, here's what we observed, here's the gap between them. One at a time, across 15 separate behaviors, he laid that comparison out publicly and formally. And that process, whatever drove it, produced a far more detailed scientific picture of 3IATLAS than any single team working strictly within the conventional framework likely would have. Generated alone, the anti-tail was real, the tight focusing was measured, the thermal deficit in the jet material was quantified, the non-gravitational acceleration was tracked, the deuterium ratio was confirmed and published in Nature. The kinematic age appeared in the astrophysical journal Letters. None of it is speculation. All of it is data. And 3IATLAS, now past Jupiter and heading permanently out of our solar system, carries with it whatever explanation best fits every number its passage produced. The universe sent us something from its earliest history. We argued about it publicly. We measured it obsessively. We watched a Harvard astronomer count its anomalies one by one, up to 15. And by the time it left, we understood more about the chemistry of the early galaxy, the structure of interstellar objects, and the limits of our own planetary observation than we did before it arrived. Something fired a beam of light at the sun from 270 million kilometers away and held that beam steady for months. Scientists have an explanation for it, several actually, and all still being refined. The universe keeps handing us things we weren't ready for. 3IATLAS was one of them, and we're still writing the papers to explain what we saw. Drop your take in the comments. Of all these anomalies, which one do you think is hardest to explain naturally? Subscribe, because the next video follows 3IATLAS to Jupiter in March 2026, and what the Juno spacecraft captured there adds one more chapter to this story. The strangest comet in recorded history passed through our solar system. We watched it every step of the way, and 15 anomalies later, we're still not finished explaining it.